So I'm Reece. I'm at Strangelove. We built up Local Interchain. This is built on top of the Interchain test repository. You can find it as a subdirectory. And we're targeting a different market with Local Interchain than what we are with Interchain test. And I want to go over that. There'll be a couple demos in here showing the power that Local Interchain brings and the problems that we're trying to solve. Quickly, I'm going to go through who am I. I'm 22. I started in Cosmos at Craft Economy. I led the Cosmos SDK to Minecraft integration so that way that we could have chains talk over IBC to other Minecraft related chains. It was extremely breaking. And then we had Microsoft come in and shut us down. All of the code is still open source. We're super excited about it, but we just weren't able to launch the product. We did get to launch that on Juno. So I joined Juno in 2022 through 2023. And began working on developer experience tooling to make building contracts easier. And then since then, I've joined Strangelove and also now Roll Chains to begin further expanding that out into the interchain in relations to UX. Whenever I started, there were a lot of tools that I wish I had, and I made note of those tools of confusing areas. And so I was able to go through my list, see what the biggest problems I had onboarding, as well as others that I helped onboard into Cosmos, and then solve those for them by building up those solutions, abstracting away the complexities, and bringing that to market. So a couple of things that I've built are Local Interchain, which we'll be discussing today, Cosmos Cache, which is an RPC REST cache that does about a 90% cache hit rate, drastically reducing infrastructure cost and needs. I built a generalized interchain indexer, CosmWasm web hosting, proof of the authority module, and also Spawn, which is a UX improvement that's building up using Local Interchain under the hood. The problem is that local development environments are extremely hard. They're very platform specific, such as local osmosis, local Terra, where it's built for its own platform with very limited expandability to, say, launch another chain beside it, such as your own or one like Juno or others. You have to have lots of binaries installed where if you want to have multiple instances of Cosmos Hub, you've got to install multiple of those, rename them, chmod, and like all of this setup is required. And it's a lot of headache for someone that just wants to launch a chain and test it with IBC. There's a lot of bash. It's a lot more bash than what most people are comfortable with. It's typically only local where you can't actually share that to others to use your testnet because of security concerns with someone taking over with token faucet or other aspects there. And then there's a lot of OS dependencies where you're not really able to use Windows for a lot of these tools. It's mainly made for Mac. Some of them require Kubernetes, which is just another headache you have to go figure out if you're not typically a DevOps person. You're normally limited to one validator. Setting up the relayer is a hassle to go find, okay, where's that port? Go put that in your config, start it up. Oh, I'm out of funds, and go restart the process. It's extremely difficult, and it's absolutely terrible UX for new application developers, both on IBC as well as the typical chain side. So what do we really need? We need to be able to use any chain in Cosmos and ideally other ecosystems like Ethereum, Polkadot, etc. We should support all major operating systems. It needs to be very easy to configure. You should have zero blockchain experience and be able to start up a blockchain. Maybe you don't understand all of the complexities that's going on behind the scenes, but at least you have a chain where you can begin to understand how things are put together and connected. We abstract away all of the initial IBC relayer setup. That way that a user can come on, I just want to connect two chains. Great, we're going to do that for you and allow you to just get started. And then you can build on more complex protocols such as ICA. You should be able to interact in a standard language and format. If you're coming from the standard Web 2 world, you'll know Python or Java or Go. You should be able to interact in one of those languages. And we need to allow power users the ability to be able to bypass the abstractions and do exactly what they need for their given use case. Local Interchain is that solution. We have support for all Cosmos chains via Docker, as well as Ethereum. We'll have Penumbra support and Polkadot in the future as well. And whenever you're getting started, we have pre-built configs for you, which we'll go over in one of the videos. There's a REST API for interaction. This is completely optional. So by default, we have Rust, Python, Bash, and Go drivers, so that way you can use your native language of choice to interact with this testnet of multiple chains. We'll have JavaScript, TypeScript, and Java in the future. But you can also still use the standard binaries if you want that way. So if you are a power user, you interact with the standard RPC, everything will work as expected. You just don't get all of the abstraction that we built in for beginners. On the requirement side, All you need is Docker and a standard operating system. We have Windows, Linux, and both Mac support, and you do need to know some JSON, but by us giving you those configurations, we also have a CLI helper. It can automatically generate the JSON for you. We'll have web apps in the future as well to make this a very non-difficult process. So I'm going to show now the demo. This is going to build up a chain and show you kind of the format that we have here, as well as some example interaction and what that looks like. Here we've got the main local interchain repository. This is going to go through how to install it on like Windows 7, Windows 10, the different options that we have, maybe some gotchas and links to our other documentation, including the REST API and other repositories. This is a base network that is going to connect Cosmos to Terra locally, and it's going to connect them via these IBC paths that are human readable. So you just set Atom to Terra, and it's going to automatically create all of the relaying behind you. We set up the Genesis accounts for you. All of that is loaded in via the Docker images. It doesn't require any binaries locally other than local interchain. As long as you have that one binary, everything is handled for you. What we're going to do here is start a base IBC chain. This will load everything into interchain test and begin to set this up as you normally would with any other testing framework. You just don't need to know Go. We can see these starting up in Docker PS and as the Genesises are created for you. And the user can just let this sit. Because it's the first time, it's not cached, it does take a little bit longer. Here's a more complex example of a base IBC using Juno, specifying things like the coin types, number of validators. You can override host ports, so that way it's not randomized. Override config files, set Genesis modifications, as we also mentioned, accounts too, and then startup commands where once the chain is started, perform Linux-based shell commands on the testnet to set it up, whether that be setting up contracts or some other functions that you need. You can set those all up there before the chain is exposed to you. The chain has now been set up, and we can see that here where the relayer is automatically started for us between these channels. The Cosmos Hub node and Terra are open, and it looks like a standard chain, which is all handled by interchain test with the abstraction layer of local interchain on top. Here's an example bash script of how you would interact. This is ugly, but I just wanted to show if you want to use standard curl, you absolutely can with just standard post request. We also have an abstraction layer using local interchain interact that will handle these. So we have custom actions such as get channels to perform these, as well as standard queries and relayer executions, as well as executing via the binary, which we'll see in the next video. So all of this is done through Docker, no binaries except local interchain, and you don't even really need that. And then here's some of the action values that you can provide in. The reason that we have auth key is that it allows for you to take a testnet, make it public. Only your team can execute against it using this auth key password, and others can play on the testnet with the standard RPCs as they would with any other RPC network, such as other testnets. So it allows for local testnets as well as public testnets, and this was shown out with Ethos's public testnet, where we use this to set up all of that infrastructure, set up Ethereum, and then connect that all via the relayer, and we didn't have to handle any of it. It was all just done through a JSON config. So that's the base of what starting up a chain looks like and some basic interactions. Here's some more configuration showing that while on the right, yes, there's a lot of complexities that you can get into, but it's the same complexities that you'll have on setting up any other chain. So on the left, we have an Ethereum chain that follows the same format as it does on the Cosmos chain side, and we figure that out on our end for what should match and how to set that up. And you're also able to load state for an AVS eigenlayer state can load up on the Ethereum side with the same format as you would have on a standard Juno side with its configuration. So a lot of it passes right over, and we already have those defaults built out for you, so it's super simple to modify it as you need. What about consumer chains? Consumer chains are notoriously a pain to set up with governance proposals and handling all of that. We abstract all of it away. You add a single line to your consumer, and you specify, I want to link to Cosmos Hub with my local instance, in this case would be the provider, and it will handle all of that for you. So as it sets up, it will set up the relayers, it will automatically do your governance proposal, it will perform all of the Genesis needs, modify your Genesis to your liking, and then set it up, and you have full access to the ICS consumer that's connected to the provider. It has support for multiple consumers, so you can mock out an entire AEZ setup locally with using all mainnet related binaries and versions. What does client interaction look like? So we've seen that we can do post requests, but we can pull those into these drivers and allow for Python and Rust native code execution as a programmer would typically be used to. So we've got a contract here, which is going to be a CosmWasm type, and then we instantiate on the contract, and it's almost the exact same syntax for both of these. And under the hood, they're doing the same thing. We're going to instantiate the contract and run that code. Let's see that now using Python. So we're going to connect two IBC contracts over a double Juno network. So this is just two instances of Juno, and these have been automatically connected with the connections. And then we're going to launch this CW IBC example. So we started the chains. We're going to initialize both contracts. Then we're going to relay connect those, and then we're going to execute on one, and over IBC, it will interact on the other. So we've run this Python file. It's going to set up our base environment that we want outputs of JSON, and then we're going to upload these contracts to the Docker instance. So this is also going to automatically realize that they're CosmWasm files. It will upload it to the chain and then return back to you the code ID. So you don't have to deal with any of that. You just need to store it on the Docker instance, and it takes care of the rest. We then instantiate both of these contracts. This is going to show here. We query those transactions, we parse it out for you. All of it's done through just standard curl requests to local interchain, and it allows us this easy API to interact with in Python. We've interacted here. We can check that the relayer is now actually connecting these contracts that we've generated. So the relayer has now done that. Currently, we only have support for the Go relayer. We execute on the channels, so that would be channel 1, since we previously had channel 0 for transfers. We execute on that to increment it, and then we flush those packets. Once the packets are flushed on the opposite side, we should see that increase to 1, which we did. It was previously 0. So we have full IBC interaction with multiple smart contracts on multiple chains, and all we had to do was set up JSON and then interact with it in Python. No binaries required. It looks the same for Rust. With Rust, you used your native Rust syntax, and then we also have support for GitHub CI. So it's not much difficult. It's not very difficult compared to setting up interchain tests. You just run it in the background, and then you run test, and it will run all of your code, set that up, and continue on as if you're writing it in just a native language of interchain test. For our roadmap, we currently have Comet mock support. It's a work in progress. GitHub CI is not liking it, but that will drastically speed up the flows due to faster blocks. We'll have safe state in the near future as well, which will include mounting. That way, if your testnet goes down, you can just launch right back up as if nothing had happened. We want to have mainnet interaction too, so that way that your testnet locally can interact with a public node or network, and that way that you can perform other actions based off of real mainnet state. So also importing Genesis states will be one of those added features as well, kind of part of safe state. Node upgrades are not really our focus, since that's mainly for interchain test Go developers, but due to more chains coming up with Rust, we would like to add that support as well, so you can write it in Rust. We'll have native ICA, mesh security, and polytone support. You'll add a single line that says, give me these features. I want to have an ICA channel automatically set up for me, and the relayer will handle that for you. Same for mesh security and polytone, where it'll upload those pre-built contracts to your chain for you. That way you don't have to do it yourself. As I mentioned earlier, TypeScript, JavaScript, and Java clients will come in the future. We want to support all major languages that have HTTP support. It's very simple to add. If you just look at the current Python and Rust examples, it will really show you where you need to go for that. And then the big part of how does this play into full building out of a seamless platform is using Spawn. Spawn is like Ignite CLI, but we allow you to choose and pick which modules you want. And then from there, in 3 commands, you can go from a brand new chain to an entire IBC testnet that is connected to a local Cosmos Hub instance. So you would just say, Spawn, create me a new chain with proof of authority. It does that. You move into that directory and then say, make testnet, and it's going to build up all of interchain test for you and all of local interchain for you. So there's a lot of great UX improvements that this brings, and we needed this to be able to build onto that next level of abstraction for chain developers to just get started. So that concludes my talk on local interchain. Questions or suggestions, you can either email me, send me that, or open up an issue in the GitHub. We're always happy to have people that think that there are better ways to do something. We're more than happy to get those in. Thank you.
Is it all right if I jumped in a question now?
Yeah.
So as long as you can provide a Docker image, say you've got a chain in development, you're in testnet or just before testnet, as long as you can provide a Docker image, you'd be able to use this
Yes.
use this piece of software that you guys have made.
Exactly. And you can use Highliner for this, which will automatically handle that for you. This builds up. I just put it in the chat. This will build up automatically like public testnets such as Gaia, Osmosis, Juno, etc. With Spawn, we automatically package that with you. So all you have to run is make testnet. We build up the binaries and Docker images for you without you having to touch any Docker or any Docker configs. So that's one group. And then also you could just import Highliner into your current repo, make local image, done, and then now you're able to throw that onto local interchain.
And so if you already have like a whole Docker pipeline, like using tilt, everything, would you be able to bring those configurations over?
Well, all we need is just the Docker image itself. So we just build like a Docker build and then take that image. You can throw that into like a tar file and then just use that in local interchain. So you don't actually need all of your configs. You just need the final Docker image itself and then just use
Just
that.
the image.
Yep.
Okay, that's so cool. And second question, with Spawn, obviously the way you mentioned it, it seemed like a replacement for Ignite to like fully scaffold a chain.
Yes.
But obviously Ignite has the same capabilities to like add modules once you've already got a chain. Is Spawn the same way? Like, because I found Ignite to be kind of a pain in the ass sometimes. So
Yes.
if you could do that on like a pre-existing chain, you want to add some like IBC capabilities that obviously Ignite, I think, only comes with IBC transfers. So being able to add like interchain accounts just straight out the way on a pre-existing chain, is that
Yep.
something that Spawn can handle?
Spawn already does that today. We also have support for the Wasm Lite client. So you just specify, I want to use the Wasm Lite client on start. It'll automatically build that up for you. We don't currently have where you can easily add modules after the fact, but we've already built it into new. It just needs to be pulled into its own command. So that will maybe take a couple of hours to do for all of the modules we currently support. We have heard the feedback of people that had issues with Ignite CLI and we wanted to solve those pain points. So we do that where there's no comments required. Spawn just like infers it and figures it out itself because a lot of the format's the same and we handle all of the difficulty behind the scenes for you, which really helps bring up the experience. We had a testimony from Bert who was able to quickly spin up a new chain, a full upgrade to SDK version 50 from 47 in a weekend with one developer. So it's drastically increased the throughput that we can have. We want to abstract away all of those difficulties, and local interchain is a part of that, which helps with testing to ensure that everything went correct.
Wow, one weekend, that's amazing. And so I'm guessing Spawn is on like 50.3,
Spawn is on
something like.
50. Yes, yeah, it's all the latest and greatest of everything. And we're going to continue. It's easy to maintain as well. Unlike Ignite, where there's temple files, we're just native Go. And so we just embed all of those together and then we remove the different features, etc. on our side based off of what the user wants. There's a tweet in the chat that goes over a video that quickly shows in 4 minutes from just creating the chain, automatically connecting it with IBC, and being able to create a new module. It's extremely, extremely quick.
That's amazing. You guys are sick.
Cool.
Yeah. How does this compare to other interchain testing frameworks like Starship, for instance?
Yeah, so Starship is probably I would say is the closest competitor. The issue that I have personally with Starship is that it's great from it work standpoint, like it's a great product. The issue is more so the UX behind adding new features and allowing it to be easy and interacting in multiple languages. So if you want to interact with Starship, I believe you need to know JavaScript or TypeScript. That should not be a hard requirement. We have the same issue on Interchain Test where you have to use Go to interact with it. We want to allow any language. Also to mention, Starship is moving over to Local Interchain. So their entire backend is going to be using us in the future because they've agreed like that's the way to have true interchain support is to have multi-language support. And it's a lot easier to configure. It's a lot easier to set up. And so they'll be moving to our backend actually as well.
Cool. Thanks, Reece. Just a question. So with local interchain, you can also just like have automated tests that you would like to run and execute against that local
Yeah,
testnet.
so you can write your test in any language you're familiar with. If you're going to use Go, you should probably just use the standard interchain test because you probably need deeper. But for application developers that they want to just write a test, write up your test normally, and then it'll just hit it as if you were writing interchain test, just in a different language. So we have that abstraction layer to allow for that. So yeah, you build up your test, you run your test in the background, and then as long as everything goes correctly and your asserts are proper, then you're good.
Cool. So then just a question. So what's the difference then for a user? When should a user use interchain test? When local interchain?
Yeah, so the way that I see it, interchain test, if you're a module developer or protocol and you're building very low level checks, you should probably still be using interchain test because you're writing in Go. If you're planning on writing in any other language or you're building an application out itself, whether that be in Rust or just some other feature on top of a testnet, I would typically say local interchain is the way to go, as well as most smart contracts fits with the local interchain flow, because again, you're writing in Rust, you probably want to write your test in Rust. So it's really more up to the user of how much abstraction are you comfortable with. If you need extremely fine level detail, interchain test all of the way. If you don't need as much, go with local interchain.
Cool, thanks.